Okay. So, like I said, tonight we're going to go over a few different things in Fusion. But before we get to that, I want to go over our printing options. Now, I just uploaded these onto Blackboard. So I'll pull that up on the screen onto Blackboard, just under um, course content. And I just put these directly into the main file here under the introduction. Oh, and I forgot to change the title because we're not using Fusion 350, whatever. But the different printers we have access to, we'll be using this semester, and the difference between one of the options. So you can download these on your own and go through them, but I want to overview these. Now we have two main types of printers. You've probably seen the two different types and different variations, in videos online, whatever have you. We have what's called an FDM printer and an SLA printer. And this, I just compiled this between a couple of sources. The FDM printer, which is an abbreviation for fused deposition or depositing modeling, is basically an extruder. It's kind of like a hot glue gun that will move around on an axis. And what that is it takes a spool of filament, a plastic filament, and we're going to talk about the different options for materials and such. And what it does is it deposits one layer at a time, an outline and inside, an outline and an inside, and an outline and inside, and so on and so forth, until it stacks those levels up. And that's effectively the technology for 3D printing in general, in the sense that you have a standard printer prints a single image on a sheet of paper. Well, think of in terms of if you took that idea and stacked multiple sheets of paper on top, you have a vertical stacking of paper. Similar idea that, and we'll talk about how a different program actually creates these files, but it takes your virtual three-dimensional object and slices that into a bunch of single layers and then stacks those layers on top. And that's how it comes up with the 3D image to be printed. It's a stack of slices. So if that helps, hopefully that helps in at least visualizing what happens. That's what's going on. Now, for what we have, we are using, it's a company called Prusa. It's a company out of Czechoslovakia. I actually have two of these myself. They are excellent printers. Not sales pitching them for you, but if you're in the market for your own, I have been very happy with mine. There's a slew of different options as well. There's I'm sure if anybody has been mildly curious, or as you're researching for your first paper, or possibly for your second one, there's a whole slew of different companies that make similar products. But this is just the ones that we have, mainly because they work really well. Other ones, a little more tweaking involved. These ones are pretty well ready to go. But anyhow, so like I said, what an FDM printer does is it takes this spool of material and heats it up inside a chamber and basically just squirts it through a nozzle into a sliced image. And it takes those, moves it. Some printers, the bed moves down. Some printers, the head moves up. Some variation of that. So like in Fusion, as we were discussing before, if you have an object, and let me just throw something down here, and we'll just make a 20 by 20 cube, and 20 by that. So if you have an object, it will start printing the first layer, so at the bottom, and just keep stacking more and more layers until it has the finished object. And that's how really how any of them work, but that's specifically how the filament printer works. Now, there's always obviously pros and cons to any of these, and we'll talk about those in a moment. But generally, that hot material is pushed out of the extruder, deposited down. It cools as it's stacking layers. There's a whole bunch of different types. And as it says here, you can get cheaper, you can get a more expensive one. But a couple of the main factors in making and where you would want to use a filament printer, they tend to be a bit cheaper as does the cost of materials, meaning the unit itself is usually cheaper, as well as the filament. Now, of course, you can get specialized filaments, and just like you can get specialized name a thing for whatever your consumable tool is. That's often at the cost of high quality print. And I don't mean that they're poor quality prints, but you do have a limit because of it's extruding a material. So just like, squirting out of squirting hot glue out of a glue gun, cake batter out of a, I forgot what the word is for you get the big cake batter out of a squeegee bag. I completely forgot what the term for that is. You're limited by the size of the nozzle, and it kind of squishes those bands together. That's basically what happens. The other general style is a resin printer. Now, these are often referred to as SLA printers. Sorry, I was just trying to highlight just the one term there. But that stands for stereolithography apparatus. Now, yes, that's technically kind of what everything works as. Sorry, I'm clicking around here. In that a stereolithogram is a single image that has been stacked. So there's variety to that. But that's the general term for these laser resin printers. And how this works is you have a liquid resin, liquid plastic, that cures rather than being heated and cooled. It actually chemically cures, but it is hardened through exposure to UV light, ultraviolet light. And that is provided, and as you see in this cage here, or in this printer, it has this kind of semi-transparent orange lid to it. That is UV protective, so that you're not getting ambient light curing your resin. The ultraviolet light is provided by a laser inside, and it's super cool to watch. But how that works is it is either projected upwards or downward, and the general technology is called DLP, so digital light processing. Basically, hooray for lasers. But it works in the same sense in that you're taking a three-dimensional object, making a whole bunch of tiny slices, and stacking them together. This is created out of the resin bath versus extruding material out. So general overview of it is the SLA laser printers, oddly, sometimes are a bit slower. That's often because one, they don't have the option of printing a hollow or webbed because of the nature of the material. And we'll get into that explanation as we actually start to get to print things, and I'll show you how that works. But the other thing is that it is much, much higher quality. Obviously, the difference is you have the difference between what a extruder nozzle is capable of. Again, think of like if you're using a hot glue gun, how big is the hot melt glue coming through that? It's only decided by how wide that little hole is versus how fine a point is a laser. So that pretty much sums up the difference in detail. So you can look through this. I'm going to go through this in more detail, of course. It does get into the difference between different materials as well. And you see, obviously, filament, string, a whole slew of different colors. Hooray for colors. But of course, this is all sandable and sandable and paintable and all that sort. But both types are. It starts to explain here some of the different, more typical ones are called PLA, PETG, and ABS. These are the more common filaments. And these are the same kind of, often enough, the same kind of plastics you find in like plastic packaging and things like that. Now, we can get into this later, but one of the main things and drawbacks is often a lot of printing material is labeled as, oh, it's recyclable. PETG is a commonly recyclable material. However, unfortunately, unlike say a lot of plastic packaging that actually has the recycle symbol and what number that is, a printed object doesn't. So recycling places will not accept that material. The other thing is some places say, oh, it's biodegradable. Yeah, technically, yes. However, in reality, it is not, because it takes a very specific conditions for that plastic to be broken down in a controlled environment of controlled heat, humidity, and actually the introduction of a very specific bacteria. It's a naturally occurring bacteria, but not in conjunction with all the other um, criteria of temperature, that sort of thing. But anyhow, not to give you the full rundown on that, but that is a thing that you might want to look into as you're writing up some of your papers, or just to keep in the back of your head. Not saying that you can't print stuff because it's not recyclable. Not at all what I'm saying. We're going to print the hell out of stuff if anybody likes. But either way, they're available from a lot of different material, a lot of different suppliers, and they even come with different blends, as it says here. Some are mixed with wood, ceramics, metals, carbon fiber. It's really cool. I'll be honest with you. It's really neat what's available. They come in different size spools, yada, yada, yada. So the other version of that is, well, what does an SLA printer use? It uses liquid resin. Waffling there because one of the other things is that where many suppliers have created their own proprietary blends or whatever of a lot of different filaments, a lot of the resins for the SLA printers are proprietary, meaning that they are only made by that specific company. Now, of course, there's open source and third-party stuff, but it's not as standard because a lot of these are so finely tuned to use their own resins. But they offer a wide variety of materials, and the ones we're using is, again, the Formlabs printer, and we are using specifically, and I'll scroll back up, this is actually not the most current model, but it is the newer model of the ones we have. This is a Formlabs Form 2. It's not really specifically necessary to know until we get to actually getting to print stuff, because that'll be important. But we will go into that in detail when we're actually doing that. So anyway, yep, the laser, like it says here, it does tend to harden faster, meaning it actually moves faster in printing, but you're usually printing so much higher detail, it can slow down the process. So they tend to be a lot more expensive, although there are, as it says, yeah, they're less budget friendly. There's less expensive ones, but they do tend to be pretty pricey at the moment. So best possible option, find somebody that has a printer or take a class that has access to printers. So you can read over the specifics of the material as you like. There is certainly a breakdown of, as it says here, precision and smoothness. So how fine a detail, how smooth the details will be. You'll get a sense of it as we start to actually work with this stuff or with models and such. I just wanted to do an overview here. Like I said, in a filament printer, extruder type printer, the major determining factor is how large the nozzle is, how big the nozzle is. Pretty much it. There's always going to be some distortions, things like that. So all the more reason why I was saying that 3D printing is not a graded element. This is something I want you all to be able to learn about and experience. You never know what's going to happen with this stuff, because anything from the power outage to just a motor failure, who knows what. So can't really depend on that. Just like when you absolutely super really need to print something on your home printer, that's when it fails. So same deal. Now there are links to this article, and you can expand, or you can research those on your own. Where was I? Right. So the SLA printers, like I said, much higher resolution, much more accurate, because again, it's dependent on how big a laser beam it's using. So laser beam versus an actual drilled hole in a metal nozzle. Pretty easy to tell which one can print finer stuff. There's a bunch of different other stuff here. This part isn't necessarily important just yet. Just how do you remove objects from the printer? We'll talk about that when we're actually using it. Post-processing, meaning what can you do to like a filament print? Like I said, you might have like some ridging and stuff like that. Well, how can you smooth that? There's different ways of doing that. Physically altering it, be it sanding it. Some materials can actually be chemically altered, meaning certain solvent chemicals can actually slightly melt the surface and get it to smooth. Stuff we'll talk about later also. Models from an SLA printer, they are, yes, covered in a sticky resin. Because it's what's left of the resin, because it's coming out of a bathtub of, although it's a very small bathtub, of liquid resin, and they just have to be cleaned off with a mild solvent, here using isopropyl alcohol. Anyhow, major breakdown. Extruder printers tend to be a bit cheaper, as well as the consumable materials. The print quality is not as fine. The laser printers, the SLA printers, the resin printers tend to be much more expensive. Their print size is much smaller, and the materials tend to be much more expensive, but you get much higher quality. So depending on what you need and what you're wanting, that's usually that will depend on which one should you use. And we're going to talk about the options here. Now, for this first print option, we're only going to be using the filament printers, namely because I'm still repairing the resin printer for now. But we'll talk about some of the options and whether or not that actually is an option, meaning that depending on the size of the print, or rather the quality of the print and how fine a detail, some things will not print on the filament printer. And I don't mean they won't come out well. I mean that they're so small in your model that it is less than the size of the extruder nozzle. So the preparatory program will actually edit those out. But we'll find ways around that, or I got to get the resin printer working. But this is basically the breakdown between when and what we'll be using. And there is a third option. Either if you are out of this class or over the summers or anything like that, and you do not have access to these printers at the school, there are a multitude of 3D printing services. Now, I'm not telling you, recommending you, or even saying you should use that over this semester. We'll use the school's materials and tools. That's exactly what it's for. But outside of that, or you need something specialty printed, like larger than we have capabilities for, there are online options for that. So things you can look into on your own. But I just wanted to go over some of the basics of those. Now I have this other printer, or this other page. We can go over it later. Really, it's just exploring what is the difference between standard SLA and the DLP options. It's still the same technology. Really, it comes down to it's just slightly different orientations of the print bed, the object, and the laser projector. So that is something you can research on your own as it pertains, because it's not really strictly important information for what we're doing. So these are both on Blackboard already. Look over them as you like. And if nothing else, good reference material for as we get there. So I'll pause the video